Greetings, my name is Ryan Nix. I am a solutions architect with Amazon Web Services. Joining me here today is Matt. Matt, say hi.
Hey guys, my name is Matt Slaughton. I'm a principal solution architect here at Veeam Kasten, focused on our Kubernetes data protection solution.
I'm so glad that you mentioned Kubernetes because I've got a collection of customers that, as part of their modernization strategy, they are adopting the cloud, and because I'm with AWS, most of that cloud adoption comes to AWS. Another building block of part of that modernization strategy is Kubernetes being a fundamental building block. Some of those customers are using Amazon's EKS. Other customers are using existing investments such as OpenShift. Obviously, when you're coming to OpenShift, two flavors. We've got customers who are using the self-managed OpenShift container platform, or OCP. But much more recently, we're seeing a gravitation towards a managed option where somebody else can do the underfledged and heavy lifting, and we see a lot of sort of Red Hat OpenShift service on AWS or ROSA coming into the picture. I have a fun misconception now. A lot of customers, when they talk to me about container workloads, make interesting statements such as my application workload, Kubernetes, if something breaks, Kubernetes is going to pick that application workload up and move it to a different underlying container host. It can remap the storage for me. So when I combine things like my Kubernetes platform with AWS, I get that safety blanket of nothing's ever going to blow up in my face. Or everything that is in my Kubernetes empire is either in a Git repository or it is in something like a container image repository, and nothing can ever get lost. I can just replay that. Everything's stateless. There's no persistent storage here. There's a myriad of problems here. Can you run me through how big is the myth here, and what are the risks that customers that are saying these things are potentially skipping over?
For sure.
And what does Veeam Kasten bring into the picture to sort of solve this?
Absolutely. So yeah, it's something that we hear all the time as well. Obviously being Kubernetes aficionados, we know that Kubernetes was originally founded to be stateless, right? So, and when we say stateless, we mean no state in the cluster.
Correct. Relational databases being somewhere external, storage being somewhere external. And I must be honest, for the most part, architectures are exactly that. But it is, the persistence is inescapable. There will be something somewhere that you need to protect.
Absolutely. There's state somewhere, exactly. Otherwise, we don't have an application, because if we never store any data, even if it's completely off the cluster, we're not manipulating any data with our application. So what are we doing?
I mean, if you write everything to dev null, you've got really fast write, but
yes, yeah, it might go away quickly. So yeah, so really important that we consider data protection when we're looking at Kubernetes. And I'll go ahead and throw Veeam Kasten here in the middle. So you touched upon a couple things there in terms of availability and failure scenarios, right? So AWS does a fantastic job of having resiliency and having things like availability zones and ensuring that we have good availability for our underlying infrastructure, which then supports our applications.
All the AWS service is also built from the ground up to be a couple of things: secure, scalable, resilient, or some of the top there. So whether you're adopting something like an EBS volume or a relational database on RDS, EKS in itself, all of those service building blocks are resilient. When you combine that with other things, OpenShift as an example, you get an aggregation of that. But we end up with something that is a fundamental discussion point: the difference between what is DR and what is high availability in this case.
Absolutely.
If we have a look at high availability, yes, architecting things well, you take Kubernetes and you combine it with AWS, you do have the luxury that if something breaks, Kubernetes could move an application workload or a container, a pod, to another location and carry on, or maybe remap the storage. That doesn't necessarily mean that it's going to magically go and fix the thing that broke in the background. And unless you address that thing that broke, you're just whittling away at your empire until something eventually does kill you.
Yes.
So
And really important here too to consider, the scenarios where it maybe isn't an availability issue, right? So applications go down for tons of reasons, right? So maybe it is an infrastructure failure, but in this case, AWS and perhaps OpenShift has our back from like a compute or infrastructure perspective. But maybe we have accidental deletion, or dare I say the bad R word, ransomware is actually becoming a lot more.
Absolutely growing concern for many customers.
And being able to recover from a ransomware attack, that's something that out of the box Kubernetes, EKS, OpenShift can't really help with, right? It's a platform in terms of having availability and distribution of our application. But when it comes to kind of disaster scenarios, that's when we need to start looking at additional solutions.
Because that's a very valid point. So we can have Kasten protect irrespective of what Kubernetes flavor you desire, whether this is self-managed native Kubernetes or whether you're using EKS or OpenShift, Kasten has the ability to actually go and protect the clusters themselves. So we can hook into the underlying Kubernetes, we can back up the configuration of the cluster. So if we ever need to reinstantiate that entire cluster, we've got that information in Kasten. That information, the backups itself, S3 I'm assuming?
Typically that's where our target is. We're sending them to S3. Obviously, we want object lock as well to ensure that we have that ransomware protection.
Okay, so we're writing all of that information in S3. S3 is fantastic because you've got 11 nines worth of durability over there, and it is something that is highly resilient. You also are paying for storage as you use it, so this becomes a really cool way of storing what is an ever-growing backup repository. And what's really nice is you can take advantage of S3's tiered storage. So the older backups, if you do need to keep those, they become more and more cost effective as you go. That said, there's a lot of other storage over here that we want to protect. And AWS has quite a few options here to begin with. So if we have a look at something like EBS, so Elastic Block Store, we've got EFS coming into the picture. In the realm of shared storage environments that span multiple locations, I would add FSX there as well.
Really important for our VM workloads because having that read-write many is really important for that live migration capability. So these are great solutions to achieve that.
Oh, even outside of VMs, if you look at a workload running in Kubernetes that needs to be able to move around across availability zones, be highly resilient, you're going to be gravitating towards something like that anyway. Or you're going through some sort of clever way of having your application write to 2 or 3 different EBS volumes. Most of my customers have got some sort of relational database cropping around there. So if we have a look at that realm, that could be Amazon's RDS in itself. It could be something completely external. Customers bringing existing investments and running their relational database on something like EC2 itself. That could be just about anything. DB2 probably as an example there.
We can also have our databases actually in the cluster as well, right? So with the advent of PVCs and having storage attached.
Oh, wow, now you have an absolute persistence challenge. Okay. Not something I would personally do if I could avoid it, but there are absolutely use cases, and there definitely are customers that are running their relational database workloads as container workloads. It does give them a degree of portability and consistency across those elements. Is there anything here that Kasten does not protect? S3, I'd say, is probably the only one in itself. It's using that as a storage relocation. There are other Veeam products that are focused there. Kasten itself is, however, going to really be a protective layer for pretty much the data as well as the configuration for all of these. Looking at Kubernetes, there's a tremendous number of knobs, dials, and configuration contexts. We've got persistent volumes, we've got the volume claims, we've got storage maps, we've got configuration maps, we've got secrets, we've got anything that could make up a workload as a project with inside Kubernetes. Does a DevOps admin or a backup and recovery administrator have to have an intimate understanding of all of these and knit these together, or does Kasten provide them a real edge here in terms of doing the heavy lifting for them.
Yep, so absolutely. Kasten does do the heavy lifting, is the short answer to that. So to your point, in terms of restoring application workloads, we need to make sure we capture both the metadata that's describing our application, so things like a deployment spec or stateful set. We also need to make sure we capture the underlying data that's attached to it. So if you have PVCs, if you have a stateful database in the cluster, we need to capture that. But we also need to capture logical and application backups as well from something like RDS. We want to do that all in kind of one restore point. Right. Otherwise, if you don't have something like Veeam Kasten, yes, you can home roll. You can roll this.
You can do this yourself.
Yes,
but you need to be realistic that you're doing this yourself. You're trying to solve every single problem, and you need to identify the blind spots.
Yep.
Talk to me around if I run Veeam Kasten, it's running inside my Kubernetes environment. I'm deploying this into EKS, or I'm deploying it into OpenShift.
Exactly. So it's a bit of a departure from traditional backup best practices, right? So we look at Veeam Data Platform, or VDR, for existing Veeam customers. The typical wisdom was to deploy that completely in a separate failure domain, maybe a physical server that's not on the infrastructure you're trying to protect, and that way that was kind of your gold, happy outside failure domain backup solution. Kasten actually inverts that. So it's essentially we deploy via operator, as you mentioned, or via Helm into the cluster. But we treat ourselves as ephemeral, much like we treat Kubernetes, the underlying infrastructure, as ephemeral. So we can protect our catalog, we can protect our configuration. So in the event of failure, we don't tell customers to try to recover Kasten in the way that at CD, you're trying to pull back the container back up in the cluster. We say, hey, deploy a new EKS cluster, deploy a new ROSA cluster, and then you can install Kasten again and essentially reseed the data from S3 into Kasten.
Right, so you're taking that stateless approach, and you're taking advantage of the durability of S3, on AWS at least. Yeah.
Exactly.
The other question I had was available on AWS Marketplace?
Yes, yeah, so multiple consumption models. So I guess for those that are interested to check it out, free up to 5 nodes, fully featured. To consume, as I mentioned, Helm chart operator. If you do want to purchase, we are available both in a hybrid term license on the AWS Marketplace. So actually have some customers that purchase on AWS Marketplace.
Run it on premises as well. As
exactly. Or we have a pay-go as well. So it's essentially pay as you go.
Customers who have a defined migration strategy. If you have a modernization strategy, and as part of that modernization strategy, you have got the cloud as a building block and Kubernetes as a building block, I would strongly advise considering Veeam Kasten as a DR and resilience component to add into that modernization strategy. There was a fantastic white paper that was published that went through multiple use cases and a bit of a deeper dive. There's also some blog content out there, other locations that customers can go to get more immersed into the product, the capabilities, the use cases. How can they get their hands dirty?
Absolutely. A lot of content out there. A lot of it's created by yours truly. So I'm going to do a little bit of self-plug. But so obviously, first place, Veeam.com is a great place to start. There we have interactive demos and some videos. That's expanded upon on a kind of independent blog that myself and a number of Kasten architects author blogs on is veeamkasten.dev. So we have even more interactive demos there. We have very kind of specific use cases defined. So let's say you're trying to protect RDS. We have a blog on there in terms of this is how you would implement a blueprint to protect RDS database workloads. So yeah, lots of information out there. I think YouTube as well. You'll hear my voice and my colleague Matt's voice on YouTube quite a bit. So lot to consume, but hopefully it makes it very accessible for our audience here.
And we can drop some rudimentary links into the description below, so do follow the breadcrumb. Matt, as always, fantastic having you here. Thank you for joining me.
Awesome. Ryan, thank you so much. Thank you guys for watching. I really appreciate you guys taking the time.
Go out there and go play. Check out Veeam Kasten in the context of your organization.